Hello students, greetings to you all. Hope you all are safe and doing good by the grace of God. So from last class we started with a new unit which is unit 4 electric charge and electric current. This video is a continuation of it, the part 2 video. Let's move on to the motivational quote for the week. Whatever you think you become, if you consider yourself weak, you will become weak. If you consider yourself strong, you will become strong, said by Swami Vivekananda. I'll repeat it. Whatever you think you become, if you consider yourself weak, you will become weak. If you consider yourself strong, you will become strong. Yes, my dear students, so your thought matters a lot. So have a positive environment and surroundings throughout. With this motivational quote, we'll move on to the class. The topics to be concentrated in this session are electromotive force, potential difference, resistance, and electric circuit diagram. We'll quickly move on to the class. Let me start with an activity. So hope everyone would have seen this, right? So what is this? Yes, exactly. It is a water pump. So how does the water pump works? Any idea? Okay, although this water pump is filled with water, okay, the water pump is filled with water and the water will not move or circle around the tube on its own, right? When you give the pressure on the handle of the pump, then only the water flows out from it, right? Yes. So the same principle is held in the working of battery as well. Yes. If you take a circular copper wire is connected full of electrons, right? However, they are not moving in a particular direction. You need some force to push the electrons to move in a direction. So this is how we relate the battery and the water pump. So devices like electric cells and other electrical energy sources act like pump, which is pushing the charges to flow through a wire or conductor. So this pumping action of the electrical energy source is made possible by the electromotive force. So what is electromotive force? It is nothing but is pushing the electrons or pumping electric charge through the conducting wire. And the definition of it would be the EMF of an electrical energy source is 1 volt if 1 joule of work is done by the source to drive 1 coulomb of charge completely around the circuit. So this is the definition of electromotive force. Yes, so the symbol of electromotive force can be written as epsilon. Okay, this is the symbol of electromotive force. And the SI unit of electromotive force is volt, or it can be termed as joule per coulomb. So the symbol is epsilon and the SI unit of EMF would be volt or joule per coulomb. And the formula for it would be epsilon is equal to W by Q, where W is nothing but the work done and Q is nothing but the charge. So to find the EMF, we should use the formula epsilon is equal to W by Q. So we need work done and charge to find the electromotive force. So now we'll do one problem related to this. So here's the problem. The EMF of a cell is 1.5 volt. What is the energy provided by the cell to drive 0.5 coulomb of charge around the circuit? I'll repeat it. The EMF of a cell is 1.5 volt. What is the energy provided by the cell to drive 0.5 coulomb of charge around the circuit? First, you should write the given. Whatever it is given, you need to frame it. Then you relate the formula and calculate it. Okay. So what is given here? They have given epsilon, which is 1.5 volt. So EMF they have given 1.5 volt and the charge they have given as 0.5 coulomb. So what they have asked to find, what is the energy provided by the cell to drive 0.5 coulomb. So work done they have been asking. So we know the formula epsilon is equal to work done by charge. So when you substitute it, work done is equal to epsilon into Q When you substitute the formula 1.5 into 0.5, which gives 0.75 joule. So the energy provided by the cell to drive 0.5 coulomb of charge around the circuit will be 0.75 joule. So hope you are clear with this topic. Next topic we are going to move is potential difference. Let me show you one image. Okay, so here I've taken two beakers. So in beaker 1 you have water, as well as in beaker 2 you have water, and these two beakers have been connected with a narrow tube. Okay, so is there any flow happens? Think. Yes, there will be no flow of water, and so there is no change in water level. Okay, let us consider another scenario. So this beaker 2 has been lifted up, and the beaker 1 is in the same place. Now the tube is also being lifted up. Is there any flow or any change of level in water? Yes, of course, there is a change of level in water, and therefore there is a flow of water. Likewise, when a circuit is connected from one terminal to cell to another, we can't say that the electrons flow, right? Of course, electrons flow, but it doesn't flow in the direction which we possess. It needs some external force, like you should connect it with a bulb or light or so on. Yes, so this is termed to be potential difference. So what is potential difference? The amount of electrical energy converted to other form depends on potential difference. So the symbol of potential difference would be V, and the SI unit of potential difference would be volt. So the formula of potential difference would be V is equal to W by Q, where W is nothing but the work done and the Q is nothing but the charge. Okay, now how to measure potential difference? It is simple. First I ask you a question, how to measure current? We have seen in last video, right? So ammeter is the instrument which is used to measure the amount of current in a circuit. Likewise, to measure the potential difference, we use voltmeter. Okay, voltmeter is an instrument used to measure the potential difference. To measure the potential difference across a component in a circuit, the voltmeter must be connected parallel to it. So when it is connected in a circuit, the voltmeter should be connected parallel to it. Okay, so if you want to measure the potential difference across a light bulb, you need to connect the voltmeter as like this. Okay. Okay. Now let's just see two circuits. One is connected with ammeter and another one is connected with voltmeter. So see, when the circuit is connected with ammeter, the ammeter should be connected in series to it. Okay. Whereas when you connect a voltmeter in a circuit, it should be parallel to it. Okay, you can see the difference between the ammeter connection and the voltmeter connection. So if a circuit has both ammeter and voltmeter, then how that the connection should be? Okay, it should be like this. Okay, when you have voltmeter as well as an ammeter in a circuit, the ammeter should be connected in a series phase, whereas the voltmeter should be connected parallel to the battery. So this is how we connect the voltmeter and ammeter in the same circuit. Hope you're clear with it. So let us see a problem related to it. So the problem shows that a charge of 20,000 coulomb flows through an electric heater. The amount of electrical energy converted into thermal energy is 5 million joule. Compute the potential difference across the ends of the heater. So what is given here? We have work done, which is 50 lakh joule, and charge they have given us 20,000 coulomb, and we know the formula for potential difference. So what is the formula for potential difference? It is nothing but the work done by charge. So work done and charge we're just going to substitute directly into the formula, and we'll be getting the value as 250 volts. So hope you are clear with it. Okay, so let us move on to a new subtopic. which is nothing but, uh, let me ask you a question. Okay, so you have many electrical appliances at your home. Have you ever experienced shock from that? Maybe some few have experienced it. So why does the shock happens? Do you have any idea? Okay, I'll tell you. There's one material which resists the flow of current. Okay, if that material fails to work, then it leads to shock. Okay, so what would be that material? As I've already said, that one material which resists the flow of current, so it's nothing but a resistance. So resistance is very important in every electrical appliances. It resists the flow of current and it allows the limited current to flow in the circuit. That's why we use the electrical appliances safely. If this resistance fails, then it leads to shock. We can also control the amount of flow of current in a circuit with the help of resistance. Such components used for providing resistance are called as resistors. So this one type of resistor, we'll be seeing this type of resistor in our TV remotes, AC remotes, and many other appliances. You can also see it in mixie, grinder, and so on. Okay, this resistor is now being used in various electronic appliances in this modern ages. Before that, there was a rheostat. Rheostat is nothing but it shows a variable resistance, variable or desired value of resistance. So this is a rheostat. It can be used in it is used in labs, even in schools or in colleges. Once the lockdown gets over, once you go into school, once you work in the lab, you will be able to find these rheostats in your lab. Okay, so this one type of rheostat, and this is also one variable resistor. It also has various knobs to make us a desired value of resistance. Okay, and this is also a variable resistance. So these are different types of rheostats, and these three are variable resistance. This three gives variable resistance, whereas the resistor is the only one which gives a fixed resistor. And now we are going to see the symbols used in a circuit. Okay, so this symbol is used for fixed resistor, and to show that a rheostat is connected into the circuit, it is mentioned as like this. Okay, with this symbol, we can identify that the rheostat is connected in the circuit. Whereas when you connect a variable resistor, then it will be shown like this. It can be denoted with the symbol this. Hope you're clear with it. So yes, what would be the SI unit of resistance? SI unit of resistance is nothing but ohm. So 1 ohm, what is 1 ohm? 1 ohm is the resistance of a component when the potential difference of 1 volt applied across the component drives a current. So this one is a very important definition. So if they ask you define 1 ohm, you should write this definition. So 1 ohm is the resistance of a component when the potential difference of 1 volt applied across the component drives a current. So let us see common symbols in electrical circuits now. The first one, this symbol is just to denote that the wires are joined. Okay, the wire connection in the circuits are joined manner. Okay, and next one, this symbol represents that the wires are crossed. So there should be no connection between the wires. Okay, and this symbol shows that switch on or off. This symbol just denotes whether the switch is on or off. Okay. G. G is nothing but galvanometer. If you have a circuit like this also, it denotes to be galvanometer. And if it has a A, then it is ammeter. We have already seen it, right? how to connect an ammeter in a circuit and voltmeter in a circuit. So V denotes voltmeter. Next we have cell. We have seen in previous video the difference between the cell and battery. What is battery? Battery is nothing but the series combination of cell is known to be battery. So cell is one type of, it has only one positive charge and one negative charge, whereas battery has two or more positive and negative terminal. And third one we have as DC power supply, and if there is a curve in between the supply, it is an AC power supply. Then the last one we have light bulb. And the first one here we have the earth connector, and the next one we have capacitor. So what is the difference between the cell and the capacitor? It mostly looks like same, right? But the cell has one end, the longer one, and the other end, the shorter one. Whereas this capacitor has both the ends with same, equal and parallel. So this is a capacitor. So now I'll show you a circuit. You are going to find what are the electrical components present in it. So we have a switch, okay, and we have a resistance. So what type of resistance is this? We saw three types of resistance. What are they? Fixed resistance, variable resistance, and rheostat. So here, which type of resistance is given here? Yes, we have fixed resistance, and your connecting wire we have, it is denoted with the direction, and we have a cell. So hope you're clear with these components in the electrical circuit. So next we'll be seeing different electrical circuits. So there are two circuits. One is a series circuit, another one is a parallel circuit. Series is nothing but it is connected in a line, okay, series in a line, okay, and parallel is nothing but it's connected one after the other. So we'll see it. First we'll see the series circuit. So components are connected in single loop and only one pathway through which electric charge flow. Okay, so if you take out from the one bulb from the series circuit, everything will go. Okay, current in each point of the circuit is same. The current remains same, but since it is connected in series circuit, if you disturb one component, then the entire current flow stops. This would be the drawback of series circuit. Next, we'll see the parallel circuit. The parallel circuit is nothing but it is connected one after the another. Components are connected in two or more loops. So more than one pathway through which electric charge flow. But here, when you take one of the bulb or anything, the circuit doesn't get damaged. It's still, the other lights still glows. Okay, this is the positive of parallel circuit. Potential difference across separate parallel branches are same. So now we have a quick recap what we learned in today's class. So we have seen many subtopics in today's class, right? So what are they we saw? We saw about electromotive force, potential difference, and resistance. We saw various types of resistance like resistor, fixed resistors, rheostat, and variable resistors, right? And there's one circuit, open circuit and closed circuit. Open circuit, as the name suggests, an electric circuit in which the current flow is interrupted by a broken wire or an open switch. As the name suggests, for the closed circuit, an electric circuit in which the current flows through an uninterrupted path. And we saw about series circuit and parallel circuit. So what is a series circuit? An electric current circuit in which the current flows through one path and a break in the circuit prevents the current flow. Whereas for parallel circuit, an electric circuit in which the current flows through more than one path, a break in the circuit does not prevent the flow of current. And we saw different symbols used in the circuit as well. So hope you are clear with today's class. For your follow-up work, I'm just going to give you a model making. So you can do a series circuit or a parallel circuit. Any one circuit by using cell And this simple method I've used here is a light bulb. It's just connected to the battery and it glows. Okay, this is a series circuit. You can do a parallel circuit or a series circuit. Any one circuit you need to do as a model, take a picture of it and upload it in Google Classroom. So hope you are clear with it, students. Stay home, stay safe, and thank you so much for your patient listening.